Hello, geometry students. We're going to continue our discussion today about when we have two or more lines that are intersected by another line, and that line is called a transversal. Remember, a transversal is a line that intersects two or more other lines in two or more different places. So today we're going to talk about situations where we have a transversal intersecting two lines that are parallel. So we'll be talking about parallel lines all day. So I first want to point out a really important symbol, and that is these arrowheads that we've put on the lines. Whenever you want to indicate that two lines are parallel, we'll put the arrowheads on there. So be on the lookout for those, because those will always indicate parallel lines. Okay, so the first thing we're going to talk about today is a postulate, and I want to remind you of this word postulate. Remember, the word postulate means a statement that is accepted as true without proof. We couldn't prove it even if we wanted to, but once we state or establish a postulate, remember that postulate can now be one of those tools that we put in our geometry toolbox that we can use for reasons and justifications in proving other things, which we'll see later today. So we're going to talk about this corresponding angles postulate that says the following. It says if parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So let's look at this this example where we have we're given that A and B are parallel lines. We already knew that because we see the symbols here. So given that A and B are parallel, let's complete the following. Well, remember the corresponding angles postulate says that if parallel lines are cut by a transversal, then the corresponding angles are congruent. So let's look at angle 1 and determine what is the angle that corresponds to it. That would be angle 5. So angle 1 is congruent to angle 5. Okay. And then let's take a look at angle 2. So angle 2 would be corresponds to angle 6. So we would say that angle 2 is congruent to angle 6. And then continuing on, since all the pairs of corresponding angles are congruent, then we would look at angles 3 and 7. Okay, so angle 3 is congruent to angle 7. And then last but not least, we have the last pair of corresponding angles would be angle 4 and angle 8. So let's look at some examples involving parallel lines cut by a transversal that involve corresponding angles. So I just want to remind you about the postulate that we just stated that says when parallel lines are cut by a transversal, that implies that corresponding angles are congruent. Okay, so in example number 1 here, notice the marks. So we have some lines that are parallel being cut by a transversal. This x degree angle and this 110 degree angle are corresponding angles, so therefore they are congruent. So I guess I should have told you that the direction in each of these examples, our goal is to find x. So number 1, x would be 110 degrees. Okay. Now number 2, again, notice the parallel markings. So we have parallel lines cut by a transversal. So again, we have a pair of corresponding angles congruent, and if parallel lines are cut by a transversal, corresponding angles are congruent. So that means that 48 degrees is equal to that x plus 10 degrees. So we can find x by simply subtracting 10 from both sides, and we get that x is 38 degrees. If we want, we can turn that around because of the symmetric property of equality and say x is 38 degrees. Okay, now in this next example, notice that 125 and x are not corresponding angles. However, we can use the fact that I have these parallel lines cut by a transversal, so I know that if this is a 125 degree angle, then this would be a 125 degree angle. I'm going to go ahead and mark that. And then the 125 degree angle and x form a linear pair. And as we've proved in class, a linear pair of angles is supplementary. So x is just the supplement of 125 degrees. So 180 minus 125 degrees is 55 degrees. So x is equal to 55 degrees. So now let's take a look at the first of 3 theorems that we're going to talk about today. And since these are theorems, we are going to prove these theorems. Now remember, we've already stated the postulate that's called the corresponding angles postulate that says if parallel lines are cut by a transversal, then corresponding angles are congruent. So now we're going to use that postulate to help us prove this theorem called the alternate interior angles theorem, which says if, let's see, if parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent, okay? So you'll recall that a pair of alternate interior angles would be angles that are on alternating, well, first of all, they have to be non-adjacent angles, and they're angles that are on alternating sides of the transversal and on the interior of the two lines being transversed, okay? So in this situation, the hypothesis says that we have a pair of parallel lines. So in terms of this diagram, our given statement is going to be that M is parallel to N. And then our proof statement is going to be that a pair of alternate, or the pairs of alternate interior angles are congruent. So we're not going to prove it for both pairs of alternate interior angles. We're just going to prove it for one. And so in terms of this diagram, the alternate interior angles would be 1 and 3. So we are going to state then that our proof statement is angle 1 is congruent to angle 3. Okay, so this will be a pretty short proof. We're going to start with the given, and that is we are assuming that we have some lines that are parallel. The reason is given. The word given means we are just assuming this to be true. Now, our next statement, let's look at the reason that was given to us. Our reason is that postulate that we stated, that when parallel lines are cut by a transversal, corresponding angles are congruent. So in terms of this diagram, I'm going to state that angle 1 is congruent to angle 2 because they are corresponding angles. So we're going to say angle 1 is congruent to angle 2, okay? Now, if you look at the diagram and look at angles 2 and 3, you'll recall that they are a pair of what we call vertical angles. Whenever two lines intersect, there's always a couple of pairs of vertical angles, and we have proven in class that vertical angles are always congruent. So I'm going to make the statement that angle 2 is congruent to angle 3, okay? And we'll back that up with the vertical, I'm going to use some abbreviations here, the vertical angles congruence theorem, okay? Which says if two angles are vertical angles, then they are congruent, okay? So now if you look at steps 2 and 3 together, we have that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So therefore, we can say that angle 1 is congruent to angle 3 because we have a property of congruence that backs that up. It's called the transitive property of congruence, okay, that says if a first angle is congruent to a second and that second is congruent to the third, then the first is congruent to the third, okay? So now, notice we use this postulate to help us prove this alternate interior angles theorem. So now we've proven that. We never have to prove it again. And we can put this alternate interior angles theorem into our geometry toolbox, so now it can be used as a reason in a proof, okay? So once again, it says when parallel lines are cut by a transversal, the pairs of alternate interior angles are congruent. So now let's look at some examples where we are going to use the theorem that we just proved that says if parallel lines are cut by a transversal, then alternate interior angles are congruent. Let's use that theorem to solve for x in these problems. So in example number 1, notice we have parallel lines cut by a transversal. This 81-degree angle and this x degree angle are on alternating sides of this transversal and on the interior of the two lines being transversed. So therefore, by that theorem, we know that those alternate interior angles are congruent. So we can say that x is equal to 81 degrees, okay? In example number 2, again, we have parallel lines cut by a transversal, and we have a pair of alternate interior angles. So we know that those alternate interior angles are congruent. So 2x degrees is equal to 66. We can solve that easily for x and get that x is equal to 33. Now, I'm not going to put a degree bubble on that answer because x, the angle is not 33 degrees. The angle is 2 times 33, which is 66 degrees, okay? And then example number 3, again, I have parallel lines being cut by a transversal. I have this 80-degree angle and this x degree angle. Now, they are not alternate interior angles, okay? Because x is not on the interior of the two lines. But what I can do is I can use the fact that those alternate interior angles are congruent. So I can mark this an 80-degree angle, and then notice that 80 and the x degree angle form a linear pair. They're adjacent angles and their non-common sides form a straight line. So they form a linear pair, which means they're supplementary. So x is the supplement of that 80 degree angle. So x is equal to 100 degrees because 80 degrees plus 100 degrees is 180 degrees. Our next theorem is called the alternate exterior angles theorem, and it says the following. It says if parallel lines are cut by a transversal, then the conclusion is the pairs of alternate exterior angles are congruent. So we're going to prove that. This is a theorem and it can be proved, again, using that corresponding angles postulate that we talked about at the beginning of this lesson. Okay, so let's write a given and a proof statement in terms of this diagram. So the hypothesis of our theorem says we have parallel lines that are being cut by a transversal. So let's write our given statement in terms of this diagram. Our two lines that are parallel are lines A and B. So we're going to say that given A is parallel to B, so we're going to assume that that's true. Then what we're going to prove that the alternate exterior angles are congruent. So in terms of this diagram, if you'll notice 1 and 3, they're on alternating sides of the transversal and they're on the exterior of the two lines being cut by the transversal. So we're going to prove that angle 1 is congruent to angle 3. Okay, so a good place to start with this proof is let's go ahead and start with the given statement. A is parallel to B. Okay, we're assuming that to be true. Now, look at our second reason, vertical angles congruence theorem. So if you look at the diagram, notice we do have a pair of vertical angles labeled here. It's angles 1 and 2. So let's go ahead and say that angle 1 is congruent to angle 2, and that can be justified by the vertical angles congruence theorem that says if two angles are vertical angles, then they are congruent. Okay? Now look at the next reason. Parallel lines cut by a transversal implies corresponding angles are congruent. So if you look at this picture and then look at the diagram, notice that 2 and 3 are a pair of corresponding angles. So let's go ahead and state that 2 is congruent to 3 because, oh, that's a funny congruent symbol. Okay, because we have that corresponding angles congruence postulate. And now, like the last theorem, like our last proof, we have 1 congruent to 2 and 2 congruent to 3. So by the transitive property of congruence, we can say that angle 1 is congruent to angle 3. That's the transitive property of congruence. Now, we proved this for one pair of alternate exterior angles. We could write another proof that would be exactly the same for the other pair, but we will just go ahead and assume we've proved it for one pair, so it's true for both. All right? So alternate exterior angles theorem. So let's look at some examples using the theorem that we just proved that when parallel lines are cut by a transversal, that implies that alternate interior angles are congruent. So in number 1, notice the markings that tell us these lines are parallel. We have a transversal. This 68 degree angle and this x degree angle are on alternating sides of the transversal and on the exterior of the two lines being transversed. So therefore we know that those two lines those two angles are congruent. So we can say that x is equal to 68 degrees. All right, and then in the next example, we have some parallel lines being cut by a transversal. We have a pair of alternate exterior angles, so we know that those angles are congruent, okay? So that means I can set the 2x plus 5 degrees equal to 125 degrees, and then we'll solve that for x. Subtract 5 from both sides, we get 2x equals 120. Then I'm going to divide both sides by 2. So x is equal to 60. And again, I'm not going to put a degree bubble on this answer because we would have to put x into this expression, take 2 times that 60 and add 5 to it to get the angle measure. All right. And then number 3, we have, oh, you know what? Let me fix something. I didn't mean it to look like this. Let me fix this real quick. Okay, this is our 99 degree angle. Okay, so now we have a pair of, I need to mark it, parallel lines being cut by a transversal. The 99-degree angle and the x-degree angle are not alternate exterior angles. They're exterior angles, but they are not on alternating sides of the transversal. So therefore, they're not congruent. However, I could do this. I could say, okay, well, this 99-degree angle would be congruent to this angle. So I'm going to go ahead and mark it 99 degrees. So now we can find x because I know that this 99-degree angle and the x-degree angle form a linear pair. So therefore, they are supplementary. So we'll take 180 and subtract 99. And we will get 61. Nope, 17 minus 9 is not 6. Sorry. We're going to get 81 degrees. 81 degrees. So now let's look at our last theorem of the day. It's called the same side interior angles theorem. And it says the following. It says that if parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary, okay? So let me underline that. So we've been looking at corresponding angles, alternate interior angles, and exterior angles, and we saw that when parallel lines are cut by a transversal, those pairs of angles are congruent, but in this case, the same side interior angles, like this angle 1 and angle 3, are not necessarily congruent. Now they could be. They're not necessarily congruent, but they're always going to be supplementary. In this case, you'll notice that angle 1 appears to be an acute angle. Angle 3 appears to be an obtuse angle. So they couldn't be congruent, could they? But they could be supplementary. So we're going to prove that right now. So let's start with our given statement, and we're going to write a given statement in terms of the diagram. So in our hypothesis, we're assuming we have some parallel lines. So in our diagram, the names of those parallel lines are P and R. So we're going to say that line P is parallel to line R for our given statement. And then we're going to prove that the pairs of same side interior angles are supplementary. So in terms of this diagram, the same side interior angles are 1 and 3. So we're going to prove that angle 1 and angle 3 are supplementary. So what we're going to do is we're going to show that angles 1 and 3 satisfy the definition of supplementary angles. We're going to show that their measures add up to 180. So starting with our given statement, we have that line P is parallel to line R. Why is that true? Because we're assuming that it's true. That's what the word given means. All right. So now if you look at the next reason, we have this reason. Parallel lines cut by a transversal implies that alternate interior angles are congruent. So take a look at the diagram. We have a pair of alternate interior angles labeled, and those would be angles 1 and 2. So our statement number 2 is going to be that angle 1 is congruent to angle 2. Okay? Now, notice the next reason. Definition of congruent angles. Remember what that definition said? It said two angles are congruent if and only if their measures are equal. So we just said that angle 1 is congruent to angle 2. So backed up by the definition of congruent angles, we can now say that the measure of angle 1 equals the measure of angle 2. Okay? Next thing I want you to notice is if you look at the diagram, look at angles 2 and 3. They are adjacent angles and their non-common sides form opposite rays. So therefore, they satisfy the definition of what we call a linear pair. We can say that angle 2 and angle 3 we can call them a linear pair because they satisfy the definition of linear pair, which says two angles form a linear pair if and only if they are adjacent and their non-common sides form opposite rays. Okay? Now, you'll recall in class we proved a theorem called the linear pair theorem that says if two angles form a linear pair, then they are supplementary. So I can say that angle 2 and angle 3 are supplementary. Supplementary. Okay? And that's backed up by the linear pair theorem. Okay? So if they're supplementary, 2 and 3, if 2 and 3 are supplementary, then I can say that their measures add up to 180 because they satisfy the definition of supplementary angles, which says two angles are supplementary if and only if their measures add up to 180 degrees. Okay, so now what we're going to do, remember, that's all well and good that 2 and 3 are supplementary, but we were trying to prove that 1 and 3 were supplementary. So what I'm going to do is I'm going to take this statement, the measure of angle 2 plus the measure, well, hold on, I wanted to outline that in a different color. Let me pick red. Change that to red. Okay, we're going to take this statement, the measure of angle 2 plus the measure of angle 3, and what we're going to do is we're going to rewrite that statement in statement 7, except we're going to take the measure of angle 2 and we're going to replace it with what it's equal to. It's equal to the measure of angle 1. Okay, so statement number 7 is a rewrite of statement number 6, except we've taken this measure of angle 2 out and we're going to put the measure of angle 1 in its place. So we're going to say that, whoops, I don't know how that turned yellow. Hold on one second. We're going to say that the measure of angle 1 plus the measure of angle 3 is 180. So the property that we just, the justification for that taking the measure of angle 2 out and replacing it with what it's equal to, that's using what's called the substitution property of equality, which says if two things are equal, we can replace one with the other. So substitution property of equality. All right, so now look what we have. We have that the measure of angle 1 plus the measure of angle 3 is 180 degrees. We were trying to prove that 1 and 3 are supplementary. So now that we've shown that their measures add up to 180 degrees, we can say that angle 1 and angle 3 are supplementary. And our reason is because they satisfy the definition of supplementary angles. Supplementary angles. Let's take a look at some examples where we're going to find x using the theorem that we just proved, that when parallel lines are cut by a transversal, same side, there, I'm using some abbreviations here. SS stands for same side, INT stands for interior. So we're going to say same side interior angles are, and then this is my abbreviated supplementary. So when parallel lines are cut by a transversal, that implies that same side interior angles are supplementary. Okay, so if we look at example number 1, notice we have X and 70. They're on the same side of the transversal, and they're in the interior of the two lines being cut by the transversal. So we know that they are supplementary. So that means that X is the supplement of 70 degrees. The supplement of 70 degrees is 110 because 70 plus 110 equals 180. Okay. And number 2, again, we have some parallel lines being cut by a transversal. So this pair of same side interior angles, same side interior angles are supplementary. So that means that 10x plus 30 degrees is the supplement of this 40 degree angle. The supplement of a 40 degree angle is 140 degrees. So we're going to say that 10x plus 30 is equal to 140 degrees, equal to the supplement of the 40 degree angle. So let's solve this equation for x real quick. So we would get that 10x is equal to 110 degrees. So I'm going to divide both sides by 10, and we get x is equal to 11. Okay, and then in the last example, 130 degree angle and the x degree angle are not same side interior angles. Okay, however, I could go ahead and find, let's find this angle, which is the supplement of this 130 degree angle. So that means that it is a 50 degree angle, okay? And then the 50 degree angle and the x degree angle form a linear pair. I'm sorry, not a linear pair. They are vertical angles, and remember, vertical angles are always congruent. So that means in this case, x is 50 degrees. Okay, so now you're going to work on a worksheet. You are going to review the postulate and the 3 theorems and their proofs that we just looked at. Okay, so if you get stuck, you can always look back at this video. And then on the back of the worksheet, you're going to be solving some problems and answering some questions involving these theorems and postulate. And so good luck on that worksheet, and I will talk to you soon.